Hi everyone, my name is Aquilas Tchanjou and I'm here to present you this paper called MSR4ML, Reconstructing Artifact Traceability in Machine Learning Repositories. Usually machine learning project consists of two main phases. So there is the two main parts, sorry. There is a part of focusing on software development and another part on the machine learning workflow. These two are mainly different because they have different steps with different purpose. For example, the software development lifecycle has three main steps consisting of the design, implementation of test or testing, and all updates are provided to the project through a version control system. While in the machine learning workflow, the machine learning part, the workflow is a bit different. There are modifications that can happen to the data engineering part or to the predictions, etc. So while modification can happen to artifacts related to machine learning workflow, modifications can also happen to the development part and the implementations. And each of these modification can impact the result of the model. And now the question we're gonna have now is how to integrate this. And but first, is it even possible to integrate this? Usually developers tend to focus either on the software part or on the model part. And what we're saying that is that why not focus on both parts at the same time? Let's first study like an example of machine learning workflow. We can see that machine learning workflow, each step can have input or output, and each output can be used in any further step. So using this information, it's we first what we did is we will try to understand all the artifacts related to our machine learning workflow, classify them, and find a way to improve and adapt all these different input, output, or step together so that we can create a link between the step the artifact. What we can see, for example, is that all artifacts of a machine learning project can exist in one version control repository. So this artifact can affect both part, as we say, either the machine learning part or the software part. And now the question is there any explicit link between machine learning or software artifact? So what we're saying is that probably not, because machine learning artifacts are mainly can be mainly filed or linked, for example, data configurations, while a software artifact are code, commutes, communication, etc. And usually developers do not explicitly describe or identify these links. So now the question that can be problematic is if there is any change in the behavior of the machine learning model. Is it possible to identify and know which side is responsible? Since there is no explicit link between machine learning and software artifact, it won't be easily possible to identify this because we do not know first like where which modification was responsible for that change of the final model. And this is mostly because there is no traceability between machine learning model and their artifacts. We propose now to leverage mining software repositories technique and apply them to machine learning project. So our framework has four main component characteristics, sorry. It's modular and scalable. It can identify and classify artifact, retrieve and extract relevant information from commit data, and it's open source and community based. So this framework is able to retrieve artifacts traceability in machine learning in different machine learning repositories. So we can have an example process here that can be what changes caused a model to perform worse. For example, what the framework is gonna do is using the model find name, it will retrieve all the artifacts that are linked to the model, mine the project commits to extract relevant informations, and with all these informations and the link, draw a history map of the model's evolution with all the artifacts, modifications that led to this specific version of the model. And we can see that this framework can work as a git blame command. So let's see a bit about the architecture of the framework. It may mostly have four main modules: a source code parser that is responsible of passing the code files into an AST node. And then the artifact usage identifier is gonna walk through the node and identify all the different artifacts. Artifacts are usually files, folders, or even links, and then this information will be provided to the artifact classifier that is going to classify all the different identified artifacts and link them with their relevant code. For example, if a data is important in a specific part of code, it will link them according to different classification rules that can be decided by the developers. And then the commit tracker is going to take all this commit information and then mine the mine the project to extract commit data related to those artifacts. So like the output can be used in many different ways. It can be used as trigger for DevOps pipeline, for example, to provide a project analysis and interface, or any just provide traceability data for further use. So the artifact usage identifier, how does it work? So it uses IO functions that are already exist. For example, when developers want to import or use any external artifact, they have to load it in the project. If it's a file, they can use the function load CSV of Panda, for example. So what we are doing is that we have a list of all these functions that can be used. And from these functions are going to be used to identify relevant node in the code to be analyzed. And then the argument value inference is going to infer the value of arguments to extract the file name, and the mode can be input, for example, or output. And then the artifact and code linker is going to link each artifact found to the code where it has been imported. And since after we have identified all these artifacts, the artifact classifier is gonna use um, rules that and these rules are used mainly to classify data set into different uh, into different tags. So we can say, for example, a specific data set that respects some rules can be a data, or it can be a configuration, or etc. So after we have all these information have been identified, the commit tracker now take all these informations, the artifacts and the link between them, and then it's able to extract to get relevant information from the repository. It can be used in two different modes. So the put mode, where it only queries, so like it will be used only when the developer need a specific information, or in push mode, where it will be running continuously and it will be monitoring the commits as they arrive, so that each time a commit arrive and it has updates informations related to any artifacts, those information will be gathered and stored somewhere. So our first results finds interesting um, precision and recall. For example, we have like it can retrieve 60% of the artifacts, which is quite interesting. We also found that recall can be improved by adding more IO functions, and so we plan to create a public repositories where developers can share and reuse their own IO functions. So for the future work, we mainly plan to complete the prototype, propose a heuristic-based method for dynamic assertion of the weight of link between artifacts, add support for more artifacts that are stored in external locations, and provide further specification for input parameters and output results of each module. Thank you.